Okay, so in kind of building up to, this is building up to relations, which build up to our favorite relations usually, our equivalence relations. There are other kinds of relations that are interesting, like order relations and so on. But I would say that before looking at this, I would make sure that you kind of understand Cartesian products, because we're going to be looking at them. But I will say, so recall, so the Cartesian product of a set A with itself, so the Cartesian product of a set A with itself, okay, which, and I'm going to give kind of some notational colors here. So I've got a Cartesian product with itself like this. So if I'm in the first coordinate, I'm red. If I'm in the second coordinate, I'm purple. Okay, gives all ordered pairs of elements of A. Okay, and then by only focusing on right, so that gave all of the ordered pairs. Okay, by focusing only on some ordered pairs, okay, we can understand how elements of A relate. Okay, so let's get into that. So first I'll kind of give you warm-up examples. Okay, so we can capture the information on A, i.e., right, so for example, if we have, so we know that 1 is less than 2, we know that 1 is less than 3, we know that 2 is less than 3, via the set, oh, sorry, this is for A equals 1, 2, 3, so that's actually all the information there, okay? So we just look at the set where we have 1, 2, corresponding to 1 is less than 2. We have 1, 3, corresponding to 1 is less than 3. And we have 2, 3, corresponding that 2 is less than 3. Okay? And this is a subset of A cross A. Okay? And then we have, so if we wanted to switch and have the greater than thing instead, well now I'm going to have, right, so instead I would write 3 is greater than 1, okay? And then and 2 is greater than 1, and 3 is greater than 2. And that records all the information, right? So this is, maybe I'll even highlight that. So this tells me 3 is greater than 1. This tells me 2 is greater than 1. And this tells me 3 is greater than 2. Okay? And so notice this is an example of where the order matters, right? And then for equality, right, so what would the pairs be? Well, now I want to know that 1 is equal to 1, 2 is equal to 2, and 3 is equal to 3. Okay, and that, again, records all the information that I need to understand, right, this is 1 is equal to 1, this is 2 is equal to 2, this corresponds to 3 is equal to 3. So by telling you which ordered pairs are in the set, I'm telling you which pairs of elements are equal. Okay? And then I said something out loud that I'm actually going to write because it's kind of significant here. So note, order here matters. Okay, so we have that, in particular, right, so we have that 1, 3 and 3, 1 are different and in different relations. So they're different and in different relations. Okay. In particular, right, so without order, we couldn't tell the difference between, corresponding to that, we have 1 is less than 3 and 3 is greater than 1, okay? Right, because for this relation, right, in this relation, we contain 1, 3, and in that relation, we contain 3, 1. Okay, great. Now, to actually give the definition, so okay, so suppose that A is a set. Whoa, weird things going on there. Suppose A is a set. Okay, then by definition, I'm going to have that relation on A okay, is a set, so it's a set R contained in A cross A, so it consists of certain ordered pairs of elements in A, okay? And then for A, B, and A, we say that A is related to B. Okay, so it's a relation on A, and what does it mean? A is related to B. Okay, and there's notation for that, so this is denoted A is related to B. Okay, if and only if we have that AB is an element of this subset. Okay, so that's the actual definition of a relation. It's just some subset of the Cartesian product, in other words, some collection of elements of some collection of ordered pairs of elements of A that are going to tell you, if this ordered pair is in this relation, that tells you that A is related to B. And that's kind of like how things worked over there.